All right, guys. So now that we have this smart object definition set up, we have everything else hooked up. Make sure you compile and save everything. Sometimes these state trees might stop working for some unknown reason. Normally, if you just compile them, they'll start working again. So just a heads up on that. It doesn't happen very often for me, but sometimes I'll notice that it doesn't work. And compile normally whenever I first open the project, it's a problem. So anyway, we can just go ahead and close that one down for now. And we don't need that anymore. Or that. And we don't really need that either. So let's go ahead and set up the state tree logic for the third person character. So we'll go ahead and open that up. And I'm going to make this really simple. I'm not going to make it very complex. In fact, this is going to be a rudimentary dumb, I guess you would say, or a simple logical system. So first we need to find a smart object. So I'm going to name this find smart object. I'm just going to copy that because that's what I'm going to name the state tree task as well. I'm not going to give it an enter condition because that's not actually really important for this because it's too simple. And you'll notice that we don't really have any tasks under here, but we're going to make our own. And that's fine. It's not difficult. If you've watched that other video, then you already understand how this all works. So I'm going to just create a tasks folder. And I'm going to create a task. And actually, I'm going to create a subfolder and I'm going to call it Smart Objects. Or you can call Smart Object Tasks, whatever you want to call it. Actually, I'm just going to call it Smart Objects. I'm going to move this under here. I'm going to call this STT as in state tree task. And I'm going to paste that in there, find smart objects. I'm going to open this up and I'm going to give it a category of custom subcategory. And I'm holding shift and pressing that backspace or that backslash button right below the backspace button and between the and above the enter button or return button on some keyboards. And so I'm going to give it a subcategory of smart objects. And then, no, I don't need another one. Yeah, we'll go ahead and say movement. Nah, we'll say utility. Now we'll call this find smart object. And that's what it'll show up as underneath here. And so we need a variable of actor type. Well, actually, let's just go ahead and override this and we'll add things as we need them. So override the enter state. And we need to get the smart object subsystem. So type in smart object subsystem. And off of here, we're going to do a find smart objects. Don't choose the smart object. We're going to choose the smart objects. I've tried using this one and I'm not sure it even works. So use the smart objects for now. There might be a specific case where you're supposed to use that other one versus using this one. So normally what I do on this request is I just promote it to a variable. and then I can set the defaults in here. And if you need to bind anything to a specific thing within here, you can still do that from the state tree. So don't be worried about making this a single variable. You'll still be able to bind stuff to individual entries inside of here. So for the user actor, that needs to be the actor. So let's go ahead and make this an actor type object reference. We're going to put it under the context category so that it automatically binds to our context actor. And off of the return, we're going to do a branch. And then I'm going to do a finish task off of here. And we're going to disable this. And what this does is it ensures that the task will fail if at any point it doesn't return any valid smart objects. And so off of here, we can get a random one, or you can just do a get off of here because it'll probably only return one unless there's, at least in our example, it'll probably return only one. Actually, I think I left that. Let's go back to that smart object definition. Let me see here. So under the smart object definition, I actually left this enabled. And the reason I know that is because it's red. If I disable it, it'll be gray. So you can enable it. It's fine. So it's going to randomly choose one of these, and it's going to play the animation in relation to that. So that's why we're doing a random one. It's just going to grab a random one. But there are ways to get the closest one, but I'm not going to really worry about that. So we need to break this. And off of the slot handle, let's see. We need to claim this slot. Let's see. If you come over here, you'll see Mark's smart object slot is claimed. So actually we didn't need the smart object subsystem for that, but we should need it again here soon. And this is going to return us a smart object claim handle structure. And it's basically storing stuff similar to this. Now in 5.3, you can't split this, but in 5.4 you can, and you'll be able to get the individual pieces off of it. So you can drag off of here and you can do an isValid smart object claim handle check. You can also mark these as free or occupied. This right here is for a behavior tree. You won't be making use of this inside of a state tree. So we just need to do an isValid check to make sure it was valid. We're going to do a branch. And we're actually not going to return true on this one because we want to use this in conjunction with another task on the same state. And if we finish this successfully, if it was successful, we just want it to move on to the next task within that state. We don't want it to complete that state. If we were to finish it successfully, it would finish the entire state, and that next one below this one would not be evaluated. And I'll show you what I mean here in a minute once we set this up. So for this to be visible and for us to be able to set this from the state tree, we need to actually make this instance editable. And under here, we can set some default values for this. And so for the query box, we're going to set a specific dimension for it. And I'm just going to put 2000 in there. And I'm going to copy that and paste it. I'm going to remove that negative and then copy and paste. And that makes us a box that's 4 centimeters wide, 4 centimeters tall, and 4,000 centimeters long. So the user tags. So on the bench, it's on the smart object definition. Whenever I was telling you guys about user tag filters, this is what determines that. So if you were to set some user tag filter here, saying that, hey, they need to match all of these specific tags, then this is where you would pass these tags in. Uh, and these would be the tags that it would be comparing against. So these can be bound. So you could set these up on the character and have that variable bound to this entry, and then it would check and filter out by this. And this would allow you to filter out the ones that the player can interact with. Basically, activity tags. You can use this to filter out the different types of benches. So if this was like a sitting bench and that's the kind of activity you wanted, you could say, okay, I only want the smart objects that the character can sit on, and that's how you would do that. Behavior definition class, we have to specify a behavior definition because there is more than one type if you have that other one enabled. So by default, it's going to require you to set this. And that's going to, well, actually, no, I'm sorry. It's actually not required. You don't actually have to set this. If you don't set this, it's not going to filter out a specific type. But if you did have both of them enabled, then it would be necessary for you to set this if you wanted to filter out only the interaction smart object behaviors. So actually, we don't need to enter that. And then this is should evaluate conditions. If there were any enter conditions for that, then this would evaluate these and it would filter out the ones that the conditions weren't met on. And so that's not actually important for us. You can leave that checked. If you leave that checked and there aren't any preconditions for interacting with this, then it'll simply grab it because obviously it meets those conditions that don't exist. So that's pretty much it for this one right here. We're going to modulize all of this stuff so that we can reuse it as much as possible. Save and compile that. And now back on your NPC. Under the tasks, go to Custom, Smart Objects, Utility, and find Smart Object. And then right here, like I said, these individual ones, you can actually, now if you click on this and it doesn't pull anything up, it's because there are no matching variable types of type gameplay tag container, for example. This will be a gameplay tag container. And so you'll need a variable of type gameplay tag container in order to bind a variable to this. So anyway, we don't need to change any of the default settings because I set it up for what we'll mostly be using. And so we're going to add another task underneath this task, but we have to create that task first, and that's going to be the use smart object. And the reason why we're not going to move to and use the smart object is because we need to move the player to the slot entrance, but we can only access the slot entrance location from the smart object state tree right now. So that requires us to actually move the character from this state tree right here. And I'll show you guys how to do that in the next video, but we're going to finish this one first. So we need one more task here. And so we'll create another state tree task. Actually, I forgot something here. I'm sorry. So we need to save this smart object slot claim handle structure. We need to save this as a variable, and this is going to be called claim handle. And we'll just go ahead and put this in the output category, since that's going to be an output. And let's go ahead and hook it up, or else it'll always be an empty reference. And I'm just going to alt click that to disconnect it and reconnect it right there. So because of the nature of these claim handles, it's actually okay if we pass these as copies instead of references, because they just hold ID values for future references. So just know you don't need to pass these by reference. They can be copies. Okay, so with that out of the way, let's go ahead and create that other task. This will be STT use smart object. Under the class settings, I'm just going to come over to these and these class settings, and I'm going to copy these. And that's going to be under utility as well. Override the enter state. Now we need a get the smart object subsystem. And we need to, actually, I'm not sure that's needed. Let's say use smart object with gameplay interaction. That's the one we need. So there's two of them there. There's a move to and use, and then there's a use. Excuse me. So we're not going to be using this one right here. In some situations, you may want to use this one, but in ours, that's going to be a problem because it's going to move us to the slot location, not the entrance location. And we need the player to move to the slot entrance location and then try to use it, because we don't want the contextual animation to play until we're at the entrance. And that's the reason why we set the entrance offset based on the animation, so that the character, whenever he went to play the contextual animation, he would be at the right offset. So that's the reason why we did that. So we need a claim handle, and we're going to promote this to a variable, and we're going to make this an input. We're going to put this in the input category. That will make sure that we don't accidentally forget to set this. And then we need a controller. So we're going to need an actor contextual reference. And we're going to make this, we're going to put this in the context category. And then off of this, since this is a player character, we're going to have to call the get AI controller off of it. And that will give us a reference to the AI controller controlling this. And we'll plug that into the controller. Yeah. Now this one will have a finish task on succeeded. So we'll go ahead and do a finish task on succeeded. And then we'll plug these two into the failed and have that fail if it failed for whatever reason. Now we don't need to make these instance editable since we put them under these categories. Input, context, and output, those don't require us to make these instance editable. So under here, let's go ahead and say use smart object. And this is what I was talking about earlier. If we would have finished this successfully, it would have skipped this one, and this would never be executed. It would automatically skip this and move straight to our transition. For this, we're not actually going to have a transition for testing purposes because the second we successfully transition out of this right here, we relinquish that slot and it causes problems. So I'll revisit how to deal with and handle that in a later video. But for the initial setup, we're not going to have this being succeeded. We're going to leave him stuck in this until we've tested everything, and then we'll set up that logic and handle it then. So under here, you'll see that we need an input, and if you try to compile, it's going to fail, and it's going to say, hey, this expects to have a binding. So what you need to do, and the reason why we put this in the same under the same state as this one, and we put it under it, is so that we can access that output. And so go over here and you'll see that we can access that find smart object claim handle. And so now that's set up. Now we are going to have problems and we are going to have to go back and fix stuff. There's a lot of moving parts in here and things are going to have to be adjusted. It's hard to get everything right the first time with a system as complex as this. So we're not going to have any transitions, like I said. We could have a transition on state failed and then just have the tree fail. So we can do that, but we're not going to have a successful transition. We're going to just stay inside of here if we don't fail. Okay, so that pretty much covers that. So in the next video, we'll set up this logic inside of here. The active will create a task where we move the character to the slot entrance location. And then in the next video after that, we'll cover the setup of the contextual animation.